Okay, let's start this math journey. Today we're going to be talking about section 2.4, using linear models. In example 1, even before we read it, I want to mention to you the idea of independent and dependent variables. And with that, we should make a real quick XY plane here. When we have the XY plane, when you're graphing numbers on the coordinate plane, the x variable in relation to any type of problem is going to be the independent variable. And y is going to be the dependent variable. Now, what I mean by that is the value of y is going to depend on the value of x. So if we read the problem here, suppose an airplane descends at a rate of 300 feet per minute from an elevation of 8,000 feet. Write and graph an equation to model the plane's elevation as a function of the time it has been descending. This sentence right here, or this part of this sentence right here, plane's elevation as a function of the time it has been descending. That sentence right there gives us the relationship we're going to be looking for. The plane's elevation as a function of the time. We could replace these words as a function of the time, the plane's elevation as it depends on the time it has been descending. So in this particular problem, time is going to be our independent variable, which we're going to graph on the x-axis. The plane's elevation depends on how long the plane has been flying or descending. So when we graph this, we need to keep that in mind, and when we go to write our equation, we need to keep that in mind. Key numbers from this problem: 300 feet per minute and 8,000 feet. Descends at a rate of 300 feet per minute. That's going to be our slope. That's going to be our change. If you keep in mind the definition of slope, the definition of slope is the change in y values over the change in x values. Thus, the change in elevation divided by or over the change in time. The 300 feet per minute is going to be our slope. This is our starting value, and in this case that's going to be our y-intercept. So to write our equation in slope-intercept form, y, the plane's elevation, is going to be equal to, now it's descending, so that's going to be a negative number indicating that it's going to be needing to go down, times the time, and we'll be expressing the time in minutes, plus 8,000 feet. Now that's our equation. So we wrote the equation, and we need to graph the equation now. And this should be a pretty easy thing to do. We should already be able to know, or be able to identify, that the y-intercept is going to be, or would be, the ordered pair. When x is 0, or at the start of the plane's descent, the plane's elevation is 8,000 feet. To graph another point, we could find the x-intercept, or the time when the plane lands, and we would do that by substituting in 0 for y. And to do the equation we just wrote. So when we do that, we get 0 is equal to negative 300x plus 800. To solve for the x, we'll add 300x to both sides. That'll give us 300x is equal to 8,000, and we divide each side by 300 to get 80 over 3, or 26.6 minutes, or 26.7 if we round, 26.6 repeating. So the x-intercept is going to be 26.7, comma 0. So we'll graph that second point, and that would be just about 27, and we would go ahead and put a graph in there, or put a line in there to graph that. And finally, we need to interpret the meaning of the y-intercept, and that would be the start of the descent. And I guess to write a good sentence, the start of the plane's descent. So there we've solved that problem there by writing the equation and graphing it. Then we described what the y-axis was, or the y-intercept, that is.